All right, so we're going to basically do the same thing that the machine was doing on those previous clips. What we're going to do is we're going to treat this equation here, y equals 3x, as our machine. And what we're going to do is we're going to create input numbers, pop them into the machine, and see what it spits out as an output number. All right, now for today's work, the nice thing is you can pick whatever numbers you like. So let's say, for example, off the top of my head, I pick 4. All right, so my input number is 4. I'm inputting it in for x. So here, for my calculations, what I'm going to do is I'm going to do 3 times 4, which is 12. And so 12 is my output number for y. Now, what we want to do here, though, is we're looking for a pattern. So what we need is we need more data. So I might pick another one. Now, again, I can just pick at random. I'm going to say 1. So if I plug in the 1, the machine does its work. 3 times 1, which is 3. And then, even though we are going to be talking about what are called linear functions, I'm going to do at least one more point. And I'd like to see that on your work as well, where you're plugging in at least 3 input values and getting out 3 output values. And my recommendation is that I know most people will probably stick to positive numbers because they're easier, but for one of the numbers, pick a negative. Let's say -2. All right, so we plug in 3 times -2. We do the work, and our function machine spits out a -6. And we do the negative just to make sure we're getting a complete picture, some on the positive side of the graph, some on the negative side for when we do actually graph these. But for now, we're just focused on the data table. All right, let's try one more like that. Let's put another example in our notes. Let's make a data table for this one. Now, once again, for the input, you get to pick. So let's say I pick 2. So the 2 goes into this input for x. And so we do our calculations here. -2 times 2 plus 5. Now, of course, we have to remember our order of operations, which is -2 times 2 is -4. And then -4 plus 5, that's 1. So an input of 2 gives us an output of 1. Pick another number. In fact, a good number to pick often, 0. So if we plug it in, -2 times 0 plus 5, well, that's going to equal 0 plus 5, which is equal to just 5. And like I said earlier, try to pick at least one negative. We want a complete picture. We don't just want positive numbers, but we want negatives as well. So let's try -3. -2, input -3 plus 5. To order of operations, we get -2 times -3 is 6. And 6 plus 5 is 11. All right, so input a 2, out spits out a 1. Input 0, we get a 5. And -3, we get an 11. All right, so this is the idea of taking an equation and pulling out the data of what this equation represents.